Some people's favorite holiday is Christmas. Maybe you got your birthday, if you consider that a holiday. Sometimes Easter, Halloween. No. No, 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 no. The best one is February 2nd, Groundhog Day. Why? Because this groundhog named Phil comes out of a hole or whatever it is at Gobbler's Knob of all places and predicts the weather for the next, I don't know, 3 months. And so here you got him. They hold him up like it's the Lion King movie. He sniffs these two rolls of paper, and then he picks one. They hold him up again.
Now this
He's
second
Simba.
day of February 2019.
Okay, it buffers. Okay.
The 133rd annual trek of the Punxsutawney Groundhog Club. Punxsutawney Phil, the Sears prognosticator of all prognosticators, was awakened from his burrow to the cheers of his thousands of faithful followers.
Okay.
In Groundhogese, Phil directed the president and the inner circle to his prediction scroll, which reads, "Down in my burrow on long winter nights, I listen to tunes to keep my mind right. From Motown to country to rap, even Bach. There's Aretha and Elvis, yeah, the Beatles rock. And your cheers at the knob really give me a thrill. Everyone singing to the world, Phil, Phil, Phil. But predicting the weather, that's my song. For 133 years, I've never been wrong. So is it early spring?
Is that true?
Or more winter forecast? Stop the music. Here is my forecast. Faithful
Did they just
followers,
rhyme forecast with forecast?
there is no shadow of me. A beautiful spring it shall be.
We did it! We did it! Woo! Finally, winter's over. All right. I'm happy about that. I'm tired of snow. I'm tired of it being cold. All right. There you guys have it. That's what I want you to learn. Anyway, we talked about speed on, what was it, Friday? Our day in between weekends. And that's what I want to recap right now is speed. So when we talk about speed, you talk about a car. What do you measure the speed in a car in? Well, that's miles per hour. So you got miles per hour. Look at that. Beautiful, beautiful job. Look at that. Wow. All right. Miles. That's a unit of what? Well, we're measuring distance there. So that's distance. Gosh, this is awful. All right, there we go. Distance over, and then what does an hour measure? Well, that measures time. Okay, well, miles per hour, we said that is measuring speed. So if distance divided by time is speed, then we can set that as an equation. All right? There we go. So this is our equation. Look at that. For speed, Microsoft Paint always comes in handy. I'm a beautiful graphic designer. Distance over time equals speed, okay? We're going to use that, and you can rearrange this equation. You can multiply time by both sides, and you get distance equals speed times time, and then you can solve for time as well. But basically, I give you those equations anyway. Just know that speed equals distance over time, and an easy way to think about that is, well, we measure cars' speed in miles per hour. That's distance divided by time. Or in science class, we do it a lot in meters per second. Well, meters goes on top. That's distance. Second is time. So meters per second. That's speed. So for example, if we're going 30 meters per second, that's how you denote that. That means I'm going a distance of 30 meters in 1 second. So if I were going 30 miles per hour, that means I'm going 30 miles distance in 1 hour. So that's what speed is. It's a ratio of how far are you going per unit time. So we did some of these examples in class. Let's take a look at them. A baseball is thrown a distance of 20 meters. Okay, so that's distance. Let's go ahead and label that. So let's use a red. I'll do D for distance. What is its speed? Okay, so we're trying to find speed if it takes 0.5 seconds to cover that distance. Okay, and that's our time. So we have distance, we have time, we are looking for speed. So what equation up here is solving for speed? Well, this one is, because we have speed alone on the left side. So if speed equals distance divided by time, we're trying to find speed equals, and I'm just going to abbreviate this, distance divided by time. All right, what's our distance here in the problem? Well, it's 20 meters. So 20 meters divided by, and then our time is 0.5 seconds. 0.5 seconds. And what does that equal? Well, if you do the math, that equals 40. And then what's our unit? Our unit is going to be meters divided by seconds, because we have meters up top and we have seconds on the bottom. So it's 40 meters per second. And that is your speed. So for these problems, what you need to do is, okay, look at what you're given. You're given distance, so label that. You're given distance. You're given time, 0.5 seconds, but you're trying to find speed. So now look at number 2. All right, how much time does it take for a bird flying at speed of 45 kilometers per hour to travel a distance of 1,800 kilometers? All right, we are given what? We are given the speed. This is the speed. So we're given S. We're given the distance, because the distance is 1,800 kilometers, so that's our D. We're trying to find time. Well, I know that too because it says how much time. So what's our equation for time? Let's look back up. Nope, no Cortana. Look back up. All right, time over here equals distance divided by speed. All right. Well, let's go back down. So we'll use, what is this? Oh, yeah. Oh, yeah. Time equals, wow, distance divided by speed. All right, simple enough. What's our distance in this problem? Well, it says how long will it, or how much time does it take to travel a distance of 1,800 kilometers? All right, so distance is 1,800. Come on in, everybody. Oh my gosh, hold on. Ladies and gentlemen, this is Mr. McKenney. We're not live streaming, but he teaches 4th graders at Streetsboro. And one day we are going to rule the planet with our teaching prowess. That's all I got to say. But we're learning about speed. What do you know about speed?
The faster you go, the better.
Yeah, well,
If you're not first, you're last.
there we go. I like that better. If you're not first, you're last. You might be second. Anyway, going back to this problem. You got distance on top. You got your 1,800 kilometers. You got speed on bottom. So what's our speed in this problem? That's 45 kilometers per hour. All right, well, let's plug that in. 45 kilometers per hour. All right, and if you do the math, okay, I don't have, okay, let's get a calculator up here. Mr. Cully, you should know how to do this in your head.
Right.
I know. You would think Kent State would teach me how to do mental math this well. All right, 1,800 divided by, why are there 800 calculators up now? Divided by 45. Oh, it's 40. Okay, so same as the last problem. So 40, but what's our unit now? Well, we're trying to find time. So what's our time for this problem? Well, we're talking in terms of kilometers per hour, so our unit has to be hours. So 40 hours. That's how long it would take for a bird flying at this speed to travel a distance of 1,800 kilometers. All right? And let's look at one more. A comet is cruising through the solar system at a speed of 50,000 kilometers per hour for 4 hours. What is the total distance traveled by the comet during this time? Well, what are we given? Are we given the speed? We are. The speed is 50,000 kilometers per hour. All right, are we given distance? No, we are not, because it says what is the total distance traveled by the comet during this time? And then are we given time? We are, because it says for 4 hours up here. So time equals 4 hours. All right, so we're looking for distance, so we go back up to our equation, and we see which one solves for distance. This middle one does. Distance equals speed times time. All right, so let's write that down. Distance equals speed times time. All right, well, what's our speed here? Well, we got 50,000 kilometers per hour times 4 hours. And what do you get there? Just doing some mental math. Kent State did teach me one thing. 200,000. And then It's distance. So what would our unit be? Well, what's our unit for this problem? It's kilometers. So we are left with kilometers. All right. So that's how far it would travel in those 4 hours at that speed. So basically, what you need to do for these problems is identify what are you given. Well, I'm either given speed and distance, or I'm given distance and time, or I'm given time and speed. So there's always going to be one thing that you're left finding. And then once you figure out what you're left finding, for example, if it says what is the speed, you're trying to find speed. So go up to the equations and look for the equation to solve for speed. And then you just come in and plug in those numbers down here. And that's it. You got to look at the units. Obviously, if I'm trying to measure distance, I'm not going to, my distance down here is not going to be 200,000 seconds. That wouldn't make sense. It needs to be in some sort of unit of distance. And it's always said in the problem which unit that is. So for this one, it was kilometers per hour. So that'd be kilometers. All right, that's speed. Happy Groundhog Day.